going to do Unit 5, Module 1, Session 4, called Angle Puzzles. So for this one's going to be a bit quicker than the ones before. So first of all, we're going to review our angles. So like I said, today we're going to review angles. So think about where you might find a right angle in your house. I have right angles on my windows, on my doors, on some rugs, my desks, books, calendars, my kids' toys. You know, there are literally right angles everywhere. So you are actually going to do a seesaw activity where you're going to hunt for right angles, acute angles, and obtuse angles in your house. So these are just some examples of angles that are right that you would see at my house. This is actually, just window, front door, a rug, my student book that I have at home, things like that. Any kind of books, there are right angles in many places in my house. And then remember that angles smaller than right angles are called acute angles. So I can find acute angles on some of the designs on my coffee cup. So I actually have a coffee cup that looks very similar to this, and it has acute angles. As you can see, there are some acute angles on there, okay? I also have some of the letters on, I have a bulletin board, so the letter W, the letter K, the letter R, there's lots of acute angles on letters. One of my lamps in my house has acute angles on it. Even on the design on the lampshade, I don't have a picture of it. But even vents in the house have some acute angles on them as well. A piece of pizza. On my shoes, these are my running shoes. There are some acute angles on my running shoes as well. And also tongs for cooking. I might find some acute angles on those. So you are going to look around for acute angles as well, okay? And then also looking for angles that are larger than right angles, which would be those obtuse angles, okay? You might see an obtuse angle on a clock that you might have. If you were to open up a pair of scissors at home, you might see an acute angle there. Even outside your house, if you have a stop sign, I have one right on the corner. My house is on a corner and there's a stop sign right there. There are lots of obtuse angles. And then also, my boys love to do perler beads. They build like Minecraft characters and stuff with them, but on one of their pegboards, they have some obtuse angles there. There are also obtuse angles on my shoes. And even if I were to go back to this page for a second, there are obtuse angles even on my coffee cup on the other angles. So the blue ones that I circled were acute. These ones are obtuse. And there are even obtuse angles on this part of the vent, okay? So you can find acute, obtuse, and right angles in many places in your house. So I would love for you to go on a hunt and complete the seesaw activity that goes along with that, all right? Moving on here. If we were in the classroom right now, I would teach you this workplace. These are the instructions. If you want to play it at home, you can. But to play this game, we would need pattern blocks, a spinner, and some other things which we don't have right now. You might have some of these things at your house. Since we don't have these things, you could try to play with other things if you wanted to, but I'm just going to go through the directions. So you would spin a spinner to find out what kind of angle. So this is actually in your student book on page 171. But you would spin the spinner to find out what kind of angle to make, and you could use pattern blocks to make an example of that type of angle that you spun. You would trace the pattern blocks. So this would be an example of how you could use pattern blocks to make that type of angle. So let's say that you spun a 90-degree angle. Okay, you could use these 3 pattern blocks, put them together to make a 90-degree angle. Okay, and then you would trace the pattern on the record sheet, which would be right here. Okay, and then you would label each of the interior angles. And then you would record the equation of how the angle was made. So for example, if you were doing these 3 pattern blocks right here, you could do 3 times 30 like you see equals 90 degrees. Or if you were making a 90-degree angle and you wanted to use one of these and one of these, you could do 120 minus 30 to equal 90 degrees as well, okay? Or let's say you spun and it told you to make a 120-degree angle. You could simply use the red pattern block and the brown one to make a 120-degree angle if you were to just add 90 plus 30 to get that 120-degree angle. So this is that game. It's optional if you want to play it. I just wanted to introduce it to you, okay? I'm not going to spend too much more time on that, though, because you have this in your student book, page 171. All right, so moving on to student book, page 172. Angles in polygons. So use the following information to help solve the problems below. All right, so we know that a right angle is exactly 90 degrees and it has a square corner like you can see right there, okay? An acute angle is smaller than a right angle, so that would be that angle right there. And then an obtuse angle is larger than a right angle, which would be that angle right there. So for number 1, circle the polygon that has only acute angles. So you're only looking for the polygon that has only acute angles, okay? It's not made of any other types of angles. For number 2, circle the polygon that has only obtuse angles. Only obtuse angles. So it is literally not made of any other types of angles except for obtuse angles. For number 3, you are circling the polygon that has only right angles. And again, notice how it says polygons, which means that there is more than one correct answer for number 3, okay? So for number 1, there's only one correct answer. For number 2, there's only one correct answer. And for number 3, there are 2 correct answers for number 3. And for number 4, you are going to circle the polygon that has 2 acute angles and 2 obtuse angles. There is only one correct answer for number 4. I am not going to do this for you, boys and girls. I want you to do this on your own. I'm just kind of explaining the directions to you, okay? So I would like you to complete student book page 172 for me independently and upload into Seesaw, okay? And then, so that's part of it. The other thing that you were going to do is answer these questions. Angles and rectangles. Home connection book page 91. Alexis put 2 90-degree angles together to make a new angle. How many degrees does the new angle measure? All right, so you're going to answer that one. And then for B, what kind of angle did Alexis make? Fill in the bubble to show. Did she make an acute angle, which is less than 90 degrees? Did she make a right angle, which is exactly 90 degrees? Did she make an obtuse angle, which is more than 90 but less than 180? Or did she make a straight angle, which is exactly 180 degrees? So fill in the bubble for that. For number 2, Henry put 3 45-degree angles together to make a new angle. How many degrees does the new angle measure? So 45 times 3, you could actually solve that on the side of your paper, okay, to answer that one. And then you have to decide what kind of angle did Henry make. Fill in the bubble to show. Is it an acute angle? Is it a right angle? Is it an obtuse angle? Or is it a straight angle? Okay? And then number 3, Austin put 4 15-degree angles together to make a new angle. How many degrees does that make? So 15 times 4. Now I'm thinking back to an activity that we did the other day that had to do with clocks. I'm just going to refresh your memory on that real quick and you think about a clock, okay? And then I want you to tell me what kind of angle did Austin make, fill in the bubble. Did Austin make an acute angle? Did Austin make a right angle? Did Austin make an obtuse angle? Or did Austin make a straight angle? Okay, and then you're also going to complete Home Connection book page 92. Number 4, Claudia drew and labeled a rectangle. Here is a miniature picture of her rectangle. Use this picture to help you answer the questions below. All right, we can see that the rectangle is 43 centimeters by 37 centimeters. What is the sum of the 4 interior angles in Claudia's rectangle? Show your work. B, what is the perimeter of Claudia's rectangle? Show your work. Remember that perimeter is the distance around, okay? Distance around. What is the area of Claudia's rectangle? Area equals space that it takes up. Area equals length times width, all right? And then a challenge. Claudia colored half of her rectangle blue. What is the area of the blue part of the rectangle? Show your work. All right. So I would like you to complete Home Connection page 92, Home Connection page 91, and student book page 172. There is also a seesaw activity. So this actual lesson from me is not as long as your typical lessons. So you just have a little bit more independent work to do today and submit your work into Seesaw. And that is it for today, boys and girls. All right. Have a wonderful rest of your day. Keep working hard. I am so proud of you, and I will talk to you soon.